In this video, we're going to talk about ternary ionic compounds. In ternary ionic compounds, polyatomic ions, meaning many atom ions, are in the formula of ternary ionic compounds. A polyatomic ion is a group of nonmetals that bond as a single unit, and their names typically end in "ite" and "ate." And we can see in the periodic table there's some examples, such as acetate ammonium carbonate, where they have 8, mostly have 8, and "ite." If we look at an example such as phosphate, PO4 with the subscript of 4 and -3, it has 2 subscripts, 4 and -3. The 4 in phosphate is the species subscript, while the 3 is the charge. So in forming compounds using polyatomics, we have to be careful to exchange charges for subscripts, but not the species subscript, which is the 4. So in order to do that, if multiple polyatomic ions are required, we need to use parentheses to protect the species subscript. Some few examples. Sodium phosphate. Sodium on the periodic table is Na, and phosphate is PO. So if you look at the periodic table, we can see that sodium is right here with a valence electron of 1, while phosphate is inside with PO4 -3. Now, those are the subscripts. And for beryllium phosphate, we do the same thing. But now, there's the step to write it is we have to switch the subscripts 3 and 2, not the species subscript. That's where we have to be careful. So beryllium's original subscript is 2, while phosphate's original subscript is 3. So if we switch these two subscripts, we will get beryllium 3, phosphate 2. In nomenclature, both cation and ion keep their name. The cation normally goes first, and the anion goes last. The polyatomic ion name is already in the street name, and the street name, as in having 8, has a suffix. So here we have some examples. Let's pick one. Let's look at barium nitrate. Barium in the periodic table is Ba with the charge or valence electron of 2, and we can find barium right here, the valence electron of 2, and it's going to give away 2 electrons, making it 2 plus, positive 2. And NO, which is nitride, is NO2 -1. So here we have it. When we switch the subscripts, the -1 does not switch to Ba because we do not write the 1, while the 2 will be switch over to nitride with 2 on the outside of the parentheses, away from the species subscript. Here's an example on how to find the scientific name of a ternary ionic compound. Here we have CuOH2. Cu on the periodic table is copper, the transition metal, while OH is hydroxide, the polyatomic ion. In order to find it, we know that A is already given with 2 for the subscript, and then its charge, which is given here, is -1. And then we put this in here. 2 times -1 is -2. And since they're equal and opposite, we have 2 down here for the cation. In order to find the subscript of copper, we have to look at hydroxide one more time. This right here is not written. That means there's an imaginary 1. So we put 1 here, and then in order to find the charge, what is 1 multiplied to get to 2, and then it's +2. And to find it out, 2 right here in Roman numeral is the symbol. And we have the oxidative state, and that's done.